So, Tim, can you just run through kind of how the regulatory regime works? Because it's quite different from our normal health and safety regulator.
Yeah, it's very different because it's mostly run from Europe. So the European Aviation Safety Agency is responsible for the airworthiness of all aircraft that fly within Europe. So they are actually the authority which has the power, the responsibility for certifying new aircraft and for modifications to current aircraft. So when Eurocopter approached EASA with all of these proposed modifications, they were the ones that had the task of ensuring that they were all fit for purpose, did the job that they were supposed to do before they actually certified them and published the airworthiness directives. So it is, it's linked with the European Commission, and it is a governmental body, but it is separate from the rest of the EU. It's actually based in Cologne in Germany. So they are the ones initially with their airworthiness experts, because they do this. I mean, Airbus is a major manufacturer of fixed wing. You've got Eurocopter and Augusta-Westland, major manufacturers of helicopters. So there's an awful lot of certification that they have to do. So they are. It's nothing new for them. It's something they're used to doing, and they do a thorough job. So it was a very thorough job. You may remember there were lots of promised dates for parts and things, and the delay in every case was the fact that the European regulators had asked a few more questions, and they wanted a bit more work done, a bit more validation. So when it got to the point where they were happy with the whole process and all the modifications, that's when they published their airworthiness directive. So that was on the 16th of July. It detailed all of the modifications that were required to allow the return to service of the 225. Now, within the UK, we have the Civil Aviation Authority, and they, until October next year at least, they have responsibility for flight operations. So they have limited responsibility for airworthiness. They have none for the EC225, because it's not manufactured in the UK. So airworthiness is covered by EASA, but the operations of the aircraft and how we fly it is the CAA. And that's why they produced an operational directive originally, which prevented the flight of the 225 over hostile terrain last year. And based on the EASA airworthiness directive, they withdrew that operational directive and replaced it with a new one, which allows the 225 to fly over hostile terrain, provided all of these modifications and the changes to the maintenance schedule have been enacted. So if you follow all the details in the airworthiness directive, which relates them back to a series of quite complex service bulletins from Eurocopter, the manufacturer, which is effectively the work cards and the task cards as to how to carry out all the maintenance and how to fit the new parts and all the detail work. Once all that's been done and the procedures are followed, then we're okay to fly, or the CAA has approved the 225 to fly anywhere, including hostile terrain. So that's where we are now. So the regulatory authorities have given their approval pending modification of the aircraft.
Okay, so in addition to that, we had some independent verification of what was done here. So this outfit called Shine-In Engineering, so just to explain what they did, they were actually contracted by Eurocopter, but they're advisors on investigations, root cause investigations. They're experts in investigations and investigation process. So they were contracted by Eurocopter, but they did an independent review of the root cause analysis. They advised on it, and they ensured that everything was done properly and closed out. So there were 149 possible branches. Shannon would be there saying, right, have you eliminated number 149? I mean, at one time it was thought there was a different cause of what was going on in these gearboxes. Those all had to be ruled out and closed out properly. So that's what Shine-In did. Then the second point, and yeah, I'm an engineer, I'm not quite so like Les into the Swiss cheeses. Just this really important point about the mechanism of of how a crack starts and then causes a failure. So experts in the field are a world-renowned body, Georgia Tech Research Institute. So they were brought in and they validated this whole crack propagation thing. So let's just put it into a simple, thing. You get a crack in any sort of structure, and it starts as a little thing, and then it grows. So the part doesn't fail immediately; the crack grows through it. So this was really critical to understanding. If you've got 20, does this thing reliably? Do you know it's going to take 20 flight hours? Because if you get a little crack and it fails instantly, then you've got no drive. So this was really a critical point. And so Georgia Research, that's why they were brought in to understand that and reliably know that you have 20 hours and how much time you've got remaining before your part actually breaks into 2 bits. So it's really, really important. And then finally, Professor Burdekin went to UMIST like myself, international expert in the strength of materials. I'm going to invite Jake to say a little bit about the professor, but he basically was brought in to take a look and ensure that the findings were valid.
Thanks, Alan. Burdekin was like an extra layer, which, let's be honest about it, some people in the HSSG weren't too happy about it initially. We've got 2 renowned world experts, Shane and Georgia Tech. Why do we need a third one? The third one was essentially for, like me, John Taylor, the Balpa rep, Les, and a few others, who, after May, and having had all these assurances from all these regulatory bodies and everyone else, we're still doubtful. We wanted that additional layer of assurance so that we could come to you and say, these are the experts and we got this extra layer just to reassure ourselves. On top of that, Burdekin was able to break it down into edible chunks, understandable language, I think, far better than Georgia Tech, Shannon, or indeed the regulators were able to do it. I mean, try and read the regulatory report. It's a minefield. 3 or 4 readings and I still don't understand it. But Burdekin and that Swiss cheese model brought it down to a level that the layman here and a few others in the room were able to grasp. So it was to give us, as a group, that degree of assurance that allows us to sit here today and talk about what's been done. That was why Burdekin was brought in.